Okay, so let me get back to okay, and as I was saying, I was trying to copy and paste. Let me see if this would work. No, it won't work for that one. Let me try this one here.
You aren't sharing your screen.
Oh, I guess I forgot to do that too. Thank you. I thought I did actually. Okay, can you see the screen?
Yes.
Yes.
Okay, good. I thought I actually shared the screen earlier. Okay, so I'm just trying to see if I can, let me see here. Let me try this again. Let me try with this. Okay, it's not working. All right, I'm just going to try to work with what we have here. And you may want to record the answers as we go through them. So let's start off with this one here. So what would you say the number of significant figures represented here is?
5.
246.32.
5.
5.
5, very good. So far, so good. And that's easy because all the digits are non-zero. Okay, very good. What about this one right here? 1.008.
4.
4?
4 is correct. Why?
Because the 2 zeros are in the middle.
Exactly. The
So,
2 zeros are sandwiched between the 1 and the 8. Okay, very good. What about this one right here?
1.
1. Why?
Because it's just a 7. All the zeros are behind it.
And most importantly, there is no decimal point.
Yeah.
Right. Because there's no decimal point anywhere in this number, that means that all those zeros, the 5 zeros that you see following the 7, are insignificant. So therefore, there's only one significant digit represented here. If you had a decimal point anywhere in this number, even before the 7, then those zeros will become automatically significant. Okay, very good. What about this one right here? 107.854.
6.
6.
6, exactly. What about 0.00340?
4.
4? No, I wouldn't say that.
Or is it 2? Wait on.
Anybody else? 0.00340.
It's not 5, is it?
No, not 5.
Is it 3 significant figures?
3 significant figures is correct. Why? Can you explain why it is 3?
Maybe because there's a 0 after the 3 and the 4, and that counts
Oh.
as significant.
Right? And there's a decimal point, right? The decimal point here makes a 0 significant at the end, right? Now, these 3 zeros are not significant because they appear before the first non-zero digit, which would be the 3. All right? So while these zeros here, I'm trying to highlight. These zeros here are not significant, but this 0 here is. All right? So therefore, the total number of significant figures represented here is 3. Okay, very good. What about this one right here? 350.670.
5.
No, not correct. 6. Why is it 6?
Because the first 5 count, and then the last 0 is because of the decimal.
Exactly. The 0 at the end is significant because, as she said, the decimal point is present. But also, you need to recognize that the 0 here, right, is sandwiched between 2 non-zero digits, right? So that 0 is significant. So basically, all the digits in this value here is significant. All right, so that's a total of 6 significant figures. Okay, what about 100.3? What about that one?
4.
4 significant figures because
The zeros are in the middle.
the zeros are sandwiched between the 1 and the 3. Very good. What about 14.600? This one right here.
5.
5 significant figures because
The zeros are after the decimal, and they have the 6 before it.
right, the zeros are at the end of the number, and you have a decimal point here. So therefore, all those digits are significant. What about 1.0000?
Is it 1 or 5?
You tell me.
Uh, it's 1, right?
No, it's
No,
five.
it is 5. It is five.
Why is it 5?
Because of the decimal.
Because you have the zeros at the end of a number and you have a decimal point in that number, right? So remember, if you have zeros at the end of a number and there's a decimal point anywhere in that number, then those zeros are significant, all right? So therefore, there's a total of 5 significant figures in this number. Okay, what about 0.678?
3.
Correct, because this 0, which comes before the first non-zero digit, is not significant. So therefore, 3 significant figures is being represented there. What about 0.0001?
1.
1 significant figure, very good. And what about this one? This looks like 320,001.
That's 6.
6, exactly, because these 3 zeros are between non-zero digits. So therefore, all the digits, including the zeros, will be significant. Okay, very good. All right, so let's scroll down to another question. Identify each of the following as an example of a physical or chemical property. And the first one is that silver tarnishes when it comes in contact with hydrogen sulfide in the air. So is that a physical or chemical property of silver?
Physical?
Would not be in agreement.
No, chemical, because of the
Chemical.
hydrogen sulfide.
Right. It tarnishes. Basically, there's a reaction that takes place between the silver and the hydrogen sulfide to form the tarnish. All right. So therefore, that would be a chemical property. All right. Okay. A banana is yellow.
That is
Physical
physical.
reaction.
That is definitely physical. Before I move on, let's remind ourselves of what we mean by physical or chemical properties, right? So, and it's all in your PowerPoint or your notes. A chemical property, well, let me start with the physical property first. A physical property is a property that can be observed without the substance undergoing any chemical change, all right? So for example, water vaporizing, that would be a physical property of water because water is not undergoing any change in composition or structure. A chemical property is one where a change is occurring, and what accompanies that change is a change in the structure or chemical composition, right? So you have to keep those definitions in mind while you're trying to figure out or try to put these statements into one or the other category. So the fourth one is barium melts at 725 degrees Celsius. Is that a physical or chemical property?
Did you say number 3 was physical?
Oh, my bad. I skipped 3. Thank you. Okay, so number 3, a sheet of copper can be pounded into a bowl.
That's
That's
a
physical.
physical
That's
property.
physical, exactly. Okay, very good. Barium melts at 725 degrees Celsius.
That's physical too.
That's physical as well. Gasoline is flammable.
Chemical.
Chemical.
Chemical, because that's actually a chemical reaction taking place. When gasoline is being burnt, basically it's reacting with the oxygen from the atmosphere, and it produces mainly carbon dioxide and water, all right? Diamond is the hardest natural substance.
Physical.
Physical. Helium does not react with any other element.
Chemical.
Chemical, exactly. Even though it's not reacting with any other element, that statement is a statement of a chemical property, all right? Basically, you're saying that one of the chemical properties exhibited by helium is the fact that it does not react with other elements, all right? Okay, number 8, a bar of lead is more easily bent than a bar of aluminum of the same size.
Physical.
Physical.
Physical, exactly. Potassium metal is kept submerged in oil to prevent contact with oxygen or water.
Chemical.
Chemical, okay, very good. An apple will turn brown, that should be if left in oxygen. It's a typo. An apple will turn brown if it is left in oxygen.
Chemical.
Chemical, exactly. Diamond dust can be used to cut or grind most other materials.
Physical?
Physical.
Physical, very good. Acid in tomato sauce, I'm sorry, acid in tomato sauce can corrode aluminum foil.
Chemical.
Chemical, okay, very good. Let me see what else is here. Rocks containing carbonates can be identified because they fizz when hydrochloric acid is applied.
Chemical.
Chemical.
Chemical, very good. A piece of charcoal, which is mostly the substance carbon, glows red, gives off heat, and becomes a gray ash.
Chemical.
Chemical, exactly. Okay, and I think that's basically it for this assignment. Okay, so let me move on to, let me see here. No, not that. Let me go here. Okay, so here is another assignment. I think I gave this last semester as well. Okay, so I wish I could write on this, but I guess I can't. So let me do, I'm going to bring up my tablet here so I can use it to write on. Okay, so question 1A says an automobile achieves a gas mileage of 36.1 miles per gallon. How many kilometers can it travel on 1.0 liter of gasoline? All right. So any ideas as to how you could approach this problem here? They gave you the mileage, which is 36.1 miles per gallon. And the question gives you that the volume of gasoline in the car is 1.0 liters. And the question is asking how many kilometers can it travel on that volume, given the mileage?
We need to know how many miles are in a kilometer or vice versa, and how many
Okay.
gallons are in a liter.
Okay, good. So what you need to do is consult the table that I've posted in Canvas, right? And I have a copy of the table here with me. So what I'm going to do is write down the relationship that you just mentioned. So according to the table, where is it? I just saw it. Oh, I need to scroll down. Okay, so according to this table that I'm looking at right here, 1 gallon is equal to 3.7854 liters. Make sure I'm writing down that right. Okay, yes. So that's the relationship between the gallon unit and the liter unit. Okay. Okay, let me bring this back up. Okay, anything else I need to do? What's the next step?
Miles and kilometers.
Okay, very good. So let me bring this back up again. And let me look it up. So according to the table, write this down here, 1 mile is equal to kilometers. 1 mile is equal to 1.6093 kilometers. Okay, very good. What next? Let me go back to the question again. What next? Now that you know those relationships, what will be the next step?
Then you need to put 36.1 miles over 1 mile or 1 kilometer, and then multiply that by 1.6093 kilometers.
Okay, all right. I think I get what you're saying, but let me show you how you should actually set this up. So basically, you're going to start with the 1.0 liters, right? And you need to convert this to gallons. Okay, so you write a conversion factor where you have 1 gallon above and this number here, which is 3.7854 liters below. So you set it up this way because you want the liters units to cancel out, all right? The next step is where you convert from gallons to miles. And according to the question, let me go back to the question here. According to the question, it's 36.1 gallons per mile, right? So basically, I'm going to put 36.1 gallon down here and 1 mile up here. And the reason why we set it up this way is because we want to cancel out the gallon unit and we're left with the mile unit. And then the next step is where you convert from miles to kilometers because the question is asking for the length or the distance in kilometers. So 1 mile would be down here, 1.6093 kilometers will be up top, and we do the cancellation, and then we do our number crunching. Where's my calculator? Okay, I think this is the working one. Okay, so 1 divided by 3.7854 divided by 36.1. Okay, this is the calculator that is up, acting up. Let me try this one here. Okay, so it's 1 divided by 3.7854 divided by 36.1 times 1.6093. Okay, something is wrong here. I'm not doing something right. What am I missing?
Shouldn't you multiply the parentheses, like divide 1 by 3.7854 times 1 divided by 36.1?
Yeah, yeah, I think you're right. So 1 divided by 3.7854 divided by 36.1 and then multiply by 1. Okay, yeah, I think you're right. You're absolutely right. 1.6093. Oh, something is still not working out here. Something is still not working out here, and I can't. Let me see something here. Let me see. 1 mile, I'm checking to make sure that I'm using the right numbers. 1 mile is equal to 1.6093 kilometers, and 1 gallon is equal to 3.7854 liters. And the question says that you're given 1 liter and you're asked to figure out the mileage. So 1.0 divided by gallons. Let me try this again. Okay, according to this, the answer is 0.0117. I don't think that's correct. It should be a larger number. And I don't know what I'm doing wrong here. Let me do a quick check of something here quickly. Let me go back here. Okay, the mistake I made is right here. I inadvertently switch the mile to gallon. Hold on, let me see something here. Okay, I realize the mistake I made. So let me go back to wait a minute. Right, okay. So this is the error I made here. This here and this here should be switched. So this should be 36.1 above and 1 gallon below. I knew there was something wrong. Okay, so 1 divided by 3.7854 times 36.1 times 1.6093, all right? And the answer I got is, now in this case, you have to round off the answer to 2 sig figs, right? So the answer here is 18 kilometers.
I thought it would be 15.
Okay, let me do it again. 1 divided by 3.7854 times 36.1 times 1.6093. Yeah, you're right, 15. Okay, so this should be 15 kilometers, all right? And as I said before, you need to round this off to, oops, you need to round this off to 2 sig figs because, well, let me write the 15 here first. Right, you have to round off this answer to 2 sig figs because you have 2 sig figs here. You have 5 sig figs represented here, 3 sig figs here, and 5 sig figs here. So you round off to the lowest number of sig figs. So therefore, the answer here must be rounded off to 2 sig figs. All right. And let me just say this. So you notice that I made an error, and I realized the error after realizing that there's something wrong with the answer. And this should be a lesson to you guys. Sometimes when you do calculations, you'll make a mistake somewhere and you get an answer that don't make sense, right? And therefore you have to go back to see where you made your error. And this is something that students very often fail to do simply because they just simply do the work, put in the numbers, and accept the answer as it is without examining the answer to see if the answer actually makes sense. I saw immediately, let's put it this way, I saw immediately that the answer that I ended up with the first time I tried this problem was incorrect. So therefore I knew that I had to go back and change something. So just to let you know that sometimes that happens and you have to be careful when you're solving problems of this type. Okay, any questions about this example? Any questions?
No questions.
Okay, so going back to this here. Going back to, okay, let me close this out. Okay, where is that quiz that I will, okay, so that was what we just did. Okay, so here's another one. A 16-ounce baking soda costs 65 cents. What is the cost of baking soda per gram? What is the cost of the baking soda per gram and per kilogram? So how would you tackle this problem?
Wait, you stopped sharing your screen.
Oh, okay. I think I know what's happening. Apparently okay. I'm sorry about that, folks. Apparently when I clicked on something, the screen stopped sharing and I don't know what it is, but anyway. Okay, so here's a question. It gives you the information that 16 ounces of baking soda costs 65 cents. What is the cost of baking soda per gram and per kilogram? Any ideas?
Can we find the conversion from ounces to grams?
Okay, so let me look that up. From ounces to grams. Okay, so this is what I have. I'm going to write it down right here. So the relationship between ounces and grams is 16 ounces is equal to 453.59 grams. Okay, so that's a relationship between the ounce unit and the gram unit. Okay, so what next?
You have to convert grams to kilograms.
Okay, so the relationship between the gram unit and the kilogram unit is, write it down here, 1 kilogram is equal to 1,000 grams. All right? Okay, next step.
divide 453.59 by 1,000.
Okay, and what's that's going to give you? Let me see here. 453.59 grams by 1,000. By 1,000 what?
Grams.
Okay, now what is it supposed to achieve? Now
How
just-
many kilograms?
Okay, so if you're going to do that, then you have to make sure that the units are set up correctly. So the way I would do that is that I would multiply this here. Wait a minute. So hold on. I'm still not following. You're saying you want to find how many kilograms?
Yes,
Why would you want to do that? I just want to know I want to follow your logic.
because it's asking you to find how many kilograms and grams. So if you get your answer for
Be careful. What the question is asking for, let me go back to the question. What the question is asking for is what is the cost of the baking soda per gram and per kilogram. So it's asking for the cost per gram and per kilogram.
Shouldn't you start by writing the 65 cents first?
Okay. So let me go back to, in fact, let me write this down. 16 ounces cost, what is that, 65 cents?
Yeah.
All right. Okay, so what were you saying?
I was saying to write down the 65 cents first as like the
Okay.
first number, and then you could do what is it? 16 ounces over, well, like times, and then do 16 ounces over
Well,
over
hold on, 16 ounces, what?
wait, no, it wouldn't be over 1 gram.
Let me erase this right here. Let me erase this right here to avoid confusion. Okay. Since we're stalling a bit, let me give you a little push. What I would do is first find out the cost per ounce. So it's 65 cents over 16 ounce, right? That's the first thing. Then, since I want to find the cost per gram, I would find some way of converting the ounce unit to the gram unit. And that goes back to this right here, this relationship, right? So what I would do is put, hold on, did I see this right? Hold on, let me make sure. Right, okay. So I would put 16 ounces here. And down here, I'll put the mass in grams, which is I'm sorry, 453.59 grams, all right? So the ounce units will cancel out, and for that matter, the 16 will cancel out as well. So you're going to end up with 0.65 divided by 453.59. And that would give you, according to my calculations, 0.0, no, we have to round this off to 2 sig figs. So this would be 0.014. And the units here would be dollars per gram. Or if you want to write this in scientific notation, it would be 1.4 times 10 to the minus $3 per gram. All right, so that would be the cost per gram. And then to find the cost per kilogram, it would be multiplying 1.4 times 10 to the minus $3 per gram. And this time I would multiply by this relationship here, which is hold on, wait a minute. 1 kilogram below, and 1,000 grams above. So the gram units will cancel out, and you're going to get, in this case, 1.4 dollars per kilogram. So these are the answers here and here. All right, so that's basically how I would expect you to set it up, by using conversion factors to carry out the transformations. Okay, any questions about this one?
Why do you have to divide by the 16 ounces under the 65 cents?
Well, what I was trying to do here is find the cost per ounce.
Oh, okay.
All right. So you divide the cost, which is 65 cents, by the volume that is given, which is 16 ounces. And that kind of makes it easier for me to convert from cents per ounce to cents per grams, because all I have to do is focus on converting the ounce unit to gram unit to get this, which is the same thing as this. All right, any other questions about this one? Any other questions? Okay, so let me go back here. Let me see what's next. Okay, so these questions are dealing with significant figures in different situations, different types of mathematical operations. You know what? Let me try this. I'm trying to find an easier way to deal with. I'm going to use PowerPoint instead to deal with this. Okay, and then what I'm going to do is go back to here and copy and paste from here to the PowerPoint. Let's see if that works. Okay, so it does work. All right, so that makes life easier for me. Okay, so basically what this question is asking for you to do is to work out this here. And basically you'll be using the rules for multiplication and division when, okay, let me make this full screen. Okay, so let's remind ourselves of the rules, right? For addition, subtraction on one side and multiplication, division on the other side. So according to the rules, when you're adding and subtracting, you round off your final answer to the lowest number of decimal places of the numbers involved in that operation, all right? That's in the case of addition and subtraction. Now, in the case of multiplication and division, you round off your answer according to the lowest number of significant figures involved in the calculation, all right? So in this case, you have a combination of multiplication and subtraction, all right? So how would you tackle this particular problem?
Start by
Do the subtraction first.
I'm sorry?
Do the subtraction first.
Okay, so you do the subtraction first, right? In other words, you do what is within the parentheses, right? So
Yes.
let me do that on my calculator here. So 25.37 minus 241.6. All right? And the answer I got when I did that is minus 216.23. And I'm going to rewrite the other numbers here, 50.62 and 4.184. All right, so what will be your next step?
Wait, would you have to take off, just do 0.2 because
Exactly,
the lowest is
exactly. You'd have to round off this here to where the 2 is. And why do you do that? Because?
It's the lowest amount of decimal places.
Exactly. So therefore, I'm going to rewrite this as minus 216.2 multiplied by 50.62 multiplied by 4.184. All right? Okay, so what will be the next step?
Multiply all of that.
Okay, so let me do that here. 4.184 times 50.62 times 216.2. And I get a long string of numbers here. I don't want to write it all out. So what would you suggest I do in terms of rounding off?
Have it at
Forgot.
4 sig figs.
I'm sorry?
Keep it at 4 sig figs. Only
Right,
4
round it
numbers.
off to 4 sig figs. And
And you forgot your negative sign. And
no, the negative sign is here. You're talking about this?
yeah, but when you multiplied it, you didn't add it in there. You or didn't say you did.
Oh, yeah, it's actually on the calculator screen. So I did do that. But that's
Okay.
yeah. So the number I got here is, as I said before, a long string of numbers, but we need to round it off to 4 sig figs. So when I do that, I'm going to end up with minus 4, 5, 7, 9, and then 0. All right, with no decimal point here. All right. So this would be the final answer for that one. Minus 45790. All right. Okay. Any questions about this one? Any questions? Any questions? Okay. If there are no questions, let me put this here, discard, and let me go back to the original. And now I'm going to copy and paste this and put this in the PowerPoint document again. Okay, so this is what we're working with now. Okay, so how would you tackle this one? Oops, let me go to full screen and then do my pen thing. Okay, so how would you tackle this one?
Just subtract the numbers in the parentheses.
Okay, now there are two parentheses here. So the one I think you're referring to is this one right here, right?
Yes.
So,
Yeah, the parentheses, not the bracket.
right, well, yeah, okay, good. So the 8.92, let me do that, 8.92 minus 8.9. Okay, so this part here works out to 0.02, all right? What would be the next step?
Do 0.02 divided by 8.925.
Not quite, because there's something you need to do to this.
You have to make it 1 decimal.
Exactly. You have to round that number to 1 decimal place because this has 1 decimal place here, the 8.9, and the 8.92 has 2 decimal places. So therefore,
My bad.
yeah,
it would
so
be 0.2.
no, would be 0.0 because you'd have to drop this 2 here to make it 1 decimal place, right? So 0.0 will now be divided by 8.925 times 100.0. So when you work this out, what are you going to get? That should be easy.
0.
Well, more specifically, 0.0. Because again, when you're dividing, you have to round off according to the lowest number of significant figures. Here you have 2 sig figs here, and here you have 4 sig figs. Sig figs. So therefore, this part here works out to be 0.0 multiplied by 100.0. So what does that give you?
0.
More specifically again, 0.0. Because again, you have 2 sig figs here. Here you have 4 sig figs. So your final answer must be rounded off to 2 sig figs. So you have to be careful, folks. You have to, I mean, I understand, you know, that, you can do the arithmetic part and all of that, but you have to take into account the extent to which you round off at each stage, all right? So therefore, the final answer here would be 0.0.
Wait, but I thought you said that the 0 before the decimal doesn't count. So would it just be 1 sig fig?
Hold on, good question. Let me see here. Well, you're absolutely, you know what? You're absolutely right. How did I miss that? Hold on, let me see here. I mean, the final answer is still correct, but this should be 1 sig fig. I was incorrect in saying that it's 2 sig figs. 1 sig fig, 1 sig fig. But this is still correct. 0.0 is 1 sig fig because you need to indicate that significant figure here. The 0 here would not be significant. So this 0 here is not significant, not significant. So it's still 0.0. That's the correct answer. All right. Any questions about that one? Okay. Let me go back to here. You know what? Let me okay. Let me go to the next one. Okay, so here's another one. I'm going to copy and paste this. Okay, let me just do a new slide. Okay. How would you tackle this one?
You need to do the stuff in parentheses first.
Okay, very good. So let me do that here. So 9.4 minus 0.23 plus 21.94 plus 81.0. Okay, so when I did that, this is what I get showing up on my display. For this part here, I got 112.11. All right. So what's the next step?
You
Round
need
it
to
to
round
the
it to
lowest.
1 decimal.
Lowest number of decimal places, which would be what? How many decimal places I need to round this off to?
1,
2 or
Okay,
1.
I hear 1, I hear 2. Which one is it?
1.
1. I would say 1 because you have 1 sig fig here, 2 sig figs here, 2 sig figs here, 1 sig fig here. So therefore, this would be rounded off to 112.1 and divide by 3.1. All right. Okay, so what's the next step? I divide
Divide that.
2.1 divided by 3.1. And I get a huge string of digits here. So I need to round this off to what?
2 sig figs.
2 sig figs, right? So therefore this becomes 36. And that's basically how that is done. All right. Okay, any questions about this one? This one is a relatively easy one. Any questions? All right. Let me discard this. And let me go back to here. And I think that's the last question. Oh, there's one more. Okay, let me copy and paste this one. Okay. Go to full screen. All right, so how would you deal with this one?
Multiply the two numbers. But
You mean within the parentheses?
yes.
Okay, so let me start off with the first two here. So this would be 9.234 times 100.6. And I get a string of numbers here. So I need to round this off to what? This part here.
4
4
sig
sig figs.
4 sig figs. So according to my calculator display, 9 to 8.9 is what I got for the numerator. And I'm going to divide that by the sum of these two, right? So that would be 8.321 plus 4.026. And according to my calculator, I got a number 12.347, but I need to round this off to, let me see here. You have 3 decimal places here. You have 3 decimal places here, right? So basically, I'm just going to rewrite this number that I have on my display, which is 12.347, which is to 3 decimal places, all right? And then the next step is to divide these two, right? So I'm going to divide 92 or 928.9 by 12.347. And to what extent do I need to round off the final answer here?
4 sig figs.
4 sig figs, right? So according to my calculated display, that would be 75.23, and that would be the final answer. All right. Okay. Any questions about this one? Any questions? Any questions? All right. So get out of this, and let me go back to here, and let me check this out. Okay, we did this one already. Okay, there was another one that well, let me see here. Not that one. Not that. Here's another one which I looked up. Okay. Oh, I guess I turned off the share screen feature again. So let me turn this back on. Okay. I'm going to go here. Okay. I'm sorry about this, folks. I thought I'd brought up before class started a particular quiz. So I have to go back to here. And then here. Let me see what this is talking about. Okay, let me get out of that. Let me try a quiz. No. Okay. Let me go back up here. Okay. Let me look at this one here. Okay. Let's do this one. So let me copy and paste this here. Now we did an example of this type in class. So this should look somewhat familiar. All right. All right, so I want you to read this question. It says 50.54% of naturally occurring isotopes of bromine have an atomic mass of 78.92 units, while 49.96% of the naturally occurring isotope of bromine has an atomic mass of 80.92 units. It says calculate the average atomic mass of bromine showing all work. Okay, so any ideas as to how you tackle this problem? Well,
What is the equation for finding atomic mass?
well, um, the question is asking for the average atomic mass, right? Now, what you need to do is to find out how much of each bromine isotope contributes to the average atomic mass. And that's why they gave you the percentage and they gave you the atomic mass of the particular isotope, right? So this is the percentage of one of them. This is the atomic mass of that isotope. This is the percentage of the other isotope and the atomic mass of that isotope, right? So basically what you'd have to do is multiply the percentages by their respective atomic masses and then add up those results. And that will give you the average atomic mass of bromine. All right? So that's basically an overview of how you tackle this problem. All right? Okay, so how would you do this?
So add the percentages.
No,
Hmm.
you're not going to add the percentages. You're going
Multiply
I'm sorry?
multiply the percentage by the atomic mass.
Okay, so you multiply the 50, for example, the 50.54, well, let me just express it as a decimal number, 0.5054 multiplied by its atomic mass, which is 78.92 AMU. And you're going to do the same thing with the 0.4946 multiplied by 80.92 AMU. All right. So we have to work out each of these in turn. So let me do the first one, which is 50 point, what am I saying? 0.5054 times 78.92. Okay, so when I work that out, now I need to round this off to 4 sig figs. So when I work that out, I got 39.89 AMU. All right. And then I'm going to do the same thing for the other calculation, 0.4946 times 80.92. And according to my calculation, this works out to be equal to 40.02 AMU. All right. And then we add those two numbers together. 39.89 plus 40.02. And according to my calculation, this works out to be equal to 79.91 AMU. All right.
And then we divide by 2, right? Because we're looking for an average.
Nope. We don't. That's it. The average was worked out because we worked out the percentage, or we utilized the percentage of each isotope here, and then we simply add them together. So this is the weighted average. We call this the weighted average atomic mass.
I understand.
Okay. All right. Any other questions about this one? Any other questions? Okay. Now the next question is going to be a bit more challenging. Let me discard this. Let me go back to this. And let me scroll down. And let me Control C. Go back to PowerPoint. And paste this here. Okay. So this question, let me go back to full screen mode. Okay, so this question says, copper is made up of 2 isotopes, and it gives you the isotopes, copper 63 and 65. And it says, given copper's atomic weight of 63.546, what is the percent abundance of each isotope? And it gives you the atomic masses of each isotope, right? So the difference between this one and the previous one is that in the case of the previous one, they gave you the percentages and they're asking for the weighted average atomic mass. In this case, they gave you the weighted average atomic mass and you're asked to determine the percentages. All right. So, any ideas? How would you deal with this?
Um,
Any ideas?
well, I was gonna say it would just be like doing it backwards,
Okay.
I guess. Because for the last one, we added the two
Okay.
AMUs
So,
to find the atomic weights. So
okay, good. All right. So you're onto something here, at least at the start, right? You're saying you're working backwards. You're going to add two things to get the atomic mass, the relative atomic mass, right? So what two things, let me write this down here. So this is the weighted average atomic mass, right? AMU. So the question is, what two things would you add in order to get this number? And you may need to go back and look at what we did in the last example to follow, to kind of figure that out.
The two averages or answers from multiplying the percentage by the decimal.
Okay, so what we're going to do is, since we don't know what those percentages are, we're going to let X equal to the percentage of copper 63 and Y equal the percentage of copper 65. All right, so assuming that to be true, how would you set this up?
X times 62.9296 plus Y
Mm-hmm.
64.9278.
Okay, very good. Now,
And would you plug in 63.546 for X and Y?
no, 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 no. You're right up until when you just said that. But this is a very important step, right? Now, here's the thing about this equation, and this is something that you would have learned from your math courses, right? Your algebra courses. You have two unknowns here. You have X and Y, all right? Now, it's been a while since I've done math, right? But what I do remember is that for every unknown that you're going to have in one equation, you're going to need as many other equations for solving the other unknowns. So for example, in this case here, you have two unknowns, X and Y, which means that you're going to need two equations, one of which is already given here. So the question is, what would be the second equation which would involve these two unknowns, X and Y? Any ideas?
Would you ask?
Okay, so what I'm saying is this equation here has two unknowns, X and Y, right? You cannot solve this equation here by itself. You're going to need another equation which contains X and Y as well. So my question to you is, what would be that equation? What would be the next equation that I would write down here, which relates X and Y?
Well, you could make an equation to get X or Y by itself and then plug that back in for X or Y.
Right, but the question is, what is that equation? What is that equation?
I'm gonna take a guess. Is
Okay,
it just X plus Y equals 63.54?
no.
Okay.
You're halfway there, or maybe I would say more than halfway. It is X plus Y equals something. So the question is, what is that something? Let me give you a hint. We're assuming that there are only two isotopes of copper. You have copper 63 and copper 65. The percentage of copper 63 is X. The percentage of copper 65 is Y. Right? So what does X plus Y give you?
The sum of those two coppers.
127.8574.
Nope. Nope. Remember, we're talking about percentages. If you have only two parts to one whole, right? What's the sum of their percentages?
Wait, what? You have two?
If you have two parts in one whole, what would be the sum of their individual, when you add the individual percentages, what would be the sum?
100%?
Exactly.
Okay.
So X plus Y is equal to 100% or 1, right? So we have two equations now, right? And each equation has X and Y as the unknowns, right? So basically, what's the next step? How would you solve for X and Y?
Is this the type of equation where you have to like cancel out the y's or something, and then afterwards when you have the answer for y you can plug it in and you'll find x?
Yeah. Now, yeah, back in the days when, you know, in the dark ages when I was in high school, the term that I remember being used for two equations like this, they're called simultaneous equations. I don't know if that term is still being used in math courses today, but back then that's what we know them as. I think a student told me once that they call them something like system of equations or something like that. But you're right. And there are a couple of approaches you can take to solve this. So the way I prefer to do it is that I would say, okay, since X plus Y is equal to 1, then I would say Y is equal to 1 minus X, right? And where the Y is here, I would plug in the 1 minus X there, right? So when I do that, I'm going to end up with, let me do this to simplify things. Let me cancel out the atomic mass units here, all right? Okay, so what I'm going to end up with is 62.9296x plus, and then I'm going to put 1 minus x where the y is here. So this will become 1 minus x times 64.9278 AMU, and that will be equal to 63.546. Let me take out AMU, that should be there. It's canceled out already. And then what I would do is I would multiply, distribute this number between these two here. So this becomes 64.9278 minus 64.9278. I'm going to rewrite this here, 62.9296x, and here would be 63.546. I'm sorry, 546.
Doesn't there need to be an x next to the second 64?
You're right. X should be right here. Thank you. And then what I'm going to do is, to make things easier, I'm going to subtract minus 64.9278 from both sides. All right. So this minus this gives you 0, so they'll cancel out. And what I'm going to do is subtract this number here from this with the x beside it. So let me do 62.9296 minus 64.9278. And according to my calculations, this works out to be equal to, okay, I need to round this off to 4 decimal places. So this works out to be equal to minus 1.9982, and that would be equal to, I have to work this out, so 63.546 minus 64.9278. Okay, so according to my calculations, now this part, I have to round off to 3 decimal places because, where is that? Let me scratch it out. 3 decimal places. So this works out to, according to my, oh, and this should be X here. Can't forget that. So this works out to be equal to minus 1.382. All right. So this means that X will be equal to minus 1.382 divided by minus 1.9982. So we do this here, 1.382, oops, with a minus sign in front of it, divided by 1.9982 with a minus sign in front of it. Okay, so according to my calculations, when I round this off to 4 sig figs, I'm going to get 0.6916. I can't fit this here, all right? 0.6916. So that would be the percentage of copper 63, right? And then to get the percentage of copper 65, that would be equal to Y is equal to 1 minus 0.6916, which works out to be equal to 0.3084. All right. So the final answer is that the percentage of copper 63 is equal to 69.16%, and the percentage of copper 65 is equal to 30.84%. All right. So that's basically, I'm sorry for the jumbled look, and that's because I didn't have enough space to, to fit everything in. But this is basically how I would expect you to tackle a problem of this type. All right. Any questions about this?
Is that another way to do it? Because usually when I do these problems, I would just plug in the 0.6916 into where X is.
Yeah, that's what I did. Yeah, that's what I did.
Okay.
You'll notice here, hold on, let me show you. This is the equation that I'm using to do this right here. All I did was plugged in this value here for X. And that gives you the value for Y.
Okay.
You see that?
Yeah.
Okay. Any other questions about this? Any other questions? Any other questions? Okay. I don't think we have enough time to do any other questions. Let me just see what's oh, there's no more questions on this page. Okay, so yeah, that's basically all I have to discuss. So what's going to happen? We have completed the first 2 chapters. So later on today, what I'm going to do is post the first quiz for you to do, and I'll let you know exactly when the due date is. And that quiz will basically cover chapters 1 and 2. All right, so look out for that. All right. Are there any questions generally before we leave? Any questions?
Will the quizzes we be sending as a PDF to you?
Yes. I'll outline when I post it. I'm going to make an announcement and outline exactly what I expect in terms of how it should be submitted. All right. Okay, any other questions? Any other questions? Okay, if there are no other questions, that's basically it for today. So I'll be available later on from 1 to 5 for office hours if you have any other questions that you may not want to ask here. And that's it. Enjoy the rest of your weekend, and I'll see you next Tuesday. Take care.
Have a good day.